Okay, good evening, everybody. Oops. My name's Richard Doyle, and I'm the current president of the Tasmanian branch of the Australian Society of Soil Science. And I'd like to welcome you all along tonight to our inaugural lecture. We're the newest branch of the Soil Science Society in Australia. We've only been running for a couple of years. We're also one of the smallest. We're about 24 members, but we're building. We've had quite a successful sort of couple of years with a number of field trips and dinners. We're having another dinner tonight. And also we've been successful in a bid for the next Australian Soil Science Society conference, which is actually a big one because it's a joint Australian and New Zealand societies coming together. And so that'll be happening in Hobart in December 2012. So I know it's a wee way away yet, but planning starts for these things early to make sure that it's successful. Okay, so we've got a few little formalities to conduct before we get started with the main event. So I just remind you to turn your mobile phones off if you've got them on, if you wouldn't mind. So it's my pleasure that we've got the President of the National or Federal Council today, the President of the Australian Soil Science Society, Richard McEwen. He wants to say a couple of words before we start. Then I'll introduce Dr. Lee Sparrow, who will undertake a couple of activities before we get underway. So over to you, Richard.
Yeah, thank you, Richard. Another Richard. I'm Richard McEwen. I work for the Department of Primary Industries in Victoria, and for my sins, I'm the current President of the Australian Society, the Federal Council, and I applaud the support that TIAR have been giving to my colleague Richard Doyle here as President of the Vic branch of the Society. It's good to see the government organisations, research organisations supporting what are essentially voluntary professional organisations. The Soil Science, the Australian Society of Soil Science, try saying that when you're drunk, has been going for 55 years. And it's changed a lot over that period. We've got over 800 members. We've got now an accreditation scheme. We're really trying to raise the status of soil science as a discipline, if one can call it a discipline. And a lot of people work in soil science, from agronomy, from engineering, from physics, from chemistry, and from mathematics even, and make huge contributions to understanding what is the most complex ecosystem, extremely variable resource, natural capital on the planet. And so we do have an accreditation scheme, a certified professional soil scientist, and we're really trying to promote that within government and within commercial organisations. And without the society, that wouldn't happen. So, and this is a society event that's been hosted by our newest branch, and welcome to it. Thank you for the opportunity to speak, and look forward to hearing Wayne. I think I pass over to Lee Sparrow now.
Yeah, thank you, Richard. As was said, I'm Lee Sparrow. I'm a member of the committee of the Tasmanian branch of the Society, and before I introduce our keynote speaker, Professor Wayne Meyer, I'd just like to take a moment to explain why the branch has decided to name this event the Temple Smith Lecture. So looking around the audience tonight, I can see a number of people who have been work colleagues of Mike for various periods of Mike's career, so they probably won't. They'll know a lot of the things I'm about to say, but there are others of you here who won't. Mike devoted his career to Tasmania's primary industries, and a large part of it in particular to improving soil and land management in those industries. He was one of the first graduates in agricultural science from this university, and one of the school's first PhD students, completing a thesis on phosphate absorption and utilisation in 1974 under the supervision of Professor Bob Maneri. Mike's early years in the workforce were spent as an agronomist and plant research officer with the Department of Agriculture, as it was then, where he was responsible for research and advisory work on the nutrition of pastures and horticultural and broadacre crops. So being the jack of all trades, if you like. In 1985, Mike was appointed Senior Agricultural Officer of the Chemistry and Soil section of the Department of Agriculture, following the retirement of Keith Stackhouse, and he led this group through its various incarnations until 2001, by which time it was known as the Land and Water Management Branch, and Mike was branch chief. During this period, this group was the major group responsible for research, development and extension related to Tasmania's agricultural land, and Mike played a major role in expanding the activities of that group to include initiatives like land capability assessment, soil education, geographic information systems, earthworm research, land care, whole farm planning and land conservation legislation. So a lot of the things that we take as commonplace in the agricultural sector today were initiatives that began under Mike's leadership from that group. This expanded role necessitated the recruitment of a number of new staff, and a number of the Indians under Chief Mike during that period are here tonight. And three of us, Richard Doyle, Bill Cotching, who's also on the committee, and myself, are members of the committee. And while some of you may argue that this is a dubious legacy that Mike has left Tasmanian soil science, I know that the three of us are very pleased and thankful for the opportunity that was given to us to come to Tasmania and work here. In addition to soil science, Mike also served other agricultural disciplines with distinction. He was the state president of the Australian Institute of Agricultural Science, as it was then, in 1981, and from 1982 to 1985 he was national president of the Australian Society of Agronomy, a term which culminated in the 1985 National Agronomy Conference in Hobart. He's also been president of the Launceston Horticultural Society, and in 1988 was a chairman of the organising committee for the Launceston stage of the World Daffodil Convention. Mike's an internationally renowned breeder of daffodils, for those of you who don't know, and Abracadabra is one of his crowning jewels, if you like, in the daffodil breeding lines. Sadly, but I guess somewhat inevitably in this busy world, I lost close contact with Mike after 1999 when he transferred from Launceston to Hobart, where he eventually became manager of the department's Water Management Branch, a position he occupied until he retired in 2005. During this time, one of Mike's major responsibilities was implementing the new Water Act, as it was then, which provides a perfect segue, if you like, to this evening's proceedings, because Mike's career is a great example of the strong and necessary link between land and water management, and of the capacity of soil scientists to add value right across this debate. So I think you can all see now why we decided and felt so strongly that this lecture should bear Mike's name. The committee, having made this decision, on more than one occasion had to resist the urge to promote the evening as the Memorial Temple Smith Lecture. I have to stress, Mike, I wasn't one of them, but everyone kept talking about the memorial lecture we were going to have, and we almost had an advertisement go out with that moniker on it. But unlike much recognition of this kind, we've chosen to do this while the man concerned is still with us, thankfully, and I hope he's willing to come down now and accept this small token of our appreciation for his efforts.
Well, thanks very much, Lee, and thanks to the Tasmanian branch of the Australian Soil Science Society. I was absolutely gobsmacked when Lee rang me up and suggested that they were looking at naming it the Temple Smith Lecture, and I thought he was pulling my leg. So, but it is a huge honour, and it's to sit there and have someone go through your career is quite something. Of course, in relation to the memorial side of things, the first thing my brother said was, and he works in a university, he knows how things work, and he said, that's funny, he said, you must be on the way out because they don't usually give it to people who are alive. So I'll be able to tell him that you nearly did make that mistake. But it's great to see so many of the people I work with here today, and without further ado, I think I'll sit down and listen to Wayne. But thanks very much to the Society. I really did appreciate it. And the other thing I wanted to say was that really I happened to be in the right spot at the right time. And it was a time when there was a lot of funding coming from the Commonwealth in relation to the first National Source Program and then Landcare, and we were able to get a lot of funding to bring people like the three that are here today that Lee has mentioned to come and work in Tasmania, and they've certainly done a great job, and I applaud having a Tasmanian branch of the Australian Australian Society of Soil Science in Hobart. Thanks very much.
Okay, now to our keynote speaker. Professor Wayne Meyer was appointed to the inaugural Chair of Natural Resource Science within the School of Earth and Environmental Sciences at the University of Adelaide in March 2007. Wayne's an irrigation, crop and resource management scientist with extensive experience in irrigated crop water use, evapotranspiration, soil water balance measurement, crop system modelling and regional natural resource management. He has led research in irrigation scheduling systems and developed a range of experimental facilities for studying crop response at both the wet and dry end of the irrigation cycle. In recent times, he's worked with researchers from a range of organisations on sustainable farming systems, the application of precision agriculture techniques, and modelling natural resource management systems. During his career, Professor Meyer has held positions with CSIRO Division of Irrigation Research in Griffith, New South Wales, with Charles Sturt University, where he was appointed the Foundation Chair in Irrigation, and with CSIRO Land and Water in Adelaide, where he was the leader of the Sustainable Agriculture Program and then Deputy Chief and Business Director of the division. From 2003 until 2006, he was Chief Scientist and, for a period, Interim CEO of the CRC for Irrigation Futures. So I think you can see Wayne's well qualified to give us some insights into making the most of the irrigation developments that we have underway here in Tasmania. Thank you, Wayne, and welcome.
Thank you. Well, first of all, thank you very much for the opportunity to come and speak with you. Thank you to Richard and to Lee for the invitation. And I'd certainly like to acknowledge Mike Temple-Smith's contribution to land use in Tasmania and agriculture and soil science in particular. So congratulations on your career, Mike, and on the influence that you've brought to bear in the fine island state. Well done. Thank you. So what we're going to talk about is irrigation and Tasmania's food bowl. And just to give you an outline, I'll talk about some of the fundamental themes that overlie what I'm about to present. Talk about Australia's water resources, importance of irrigation, then some, I guess, insights and ideas that really come out of looking at irrigation systems not only in Australia but around the world over the last 30 years, and highlight some key messages and opportunities that I hope that Tasmania will exploit. If you just allow me a little indulgence to talk about Tasmanian excursions that I've had over recent years and indicate that I've kept an eye on what's happening here. So way back in 1985 I talked about specific things to do with water logging and soil aeration, that wet end of the irrigation cycle. Then in 93 at an irrigation conference in Launceston, again a more specific title to do with irrigation scheduling and why that we see poor adoption associated with that knowledge system, if you like. By 2001, when I was asked to come back and talk to again a group of irrigators and various people in extension about irrigation, was really evolved into thinking about the opportunities, threats, a much wider view about where irrigation sat and what its opportunities were. And then again in 2005 talking to a group of postgraduate students, environmental postgraduate students, talking about water and particularly the role of irrigation in the water picture of Australia. So it's been a series of interactions with Tasmania, and I've certainly enjoyed those interactions. So here's some key messages that I'd like to leave you with this evening. Australia's water resources are limited but renewable. Unlike digging stuff out of the ground, water is renewable. Demand for water will increase, but within the Australian scene, if we are sensible about it, we can certainly accommodate most of the foreseeable demand, unless of course we keep on a population increase of 3% a year, by which time, 40 years' time, we'll have 88 million in Australia, which will be quite a challenge. Irrigation, there is no doubt, irrigation increases economic activity and strengthens social viability, those things that give community their setup in terms of their services and their access to those things that help a society and a group and a community remain viable. It is really important, and we've been going through the last decade struggling with the need to define water entitlement. What do we mean by it? Define the allocation rules, the trade rules, and particularly the use rules, the licensing of use rules, and we'll come back and talk about that some more. Here are some things that are really important in terms of ensuring that irrigation is not just a short-term deal, but something which is long-term, enduring, and has all the features which will make it successful. So it talks about all of those things, everything from the vision, which determines whether or not, sort of the boundaries that you define irrigation to apply in, the governance and management. A little rule of thumb which seems to have evolved over the last 10-15 years is the need to limit the extraction. And I must say I'm concerned about the use of the language you see currently going on in MurrayDarling Basin, where we don't talk about extraction, we talk about water diversion. It's not a diversion, it's an extraction out of the system. We are extracting it and using it for another purpose, not within the river system. Distribution and application systems that need to be effective and efficient and deliver to crop water use, not just because somebody wants, some organisation needs to deliver a certain amount of water because that's where they make their money. Water trade needs to be well defined and bounded, as in any market situation. Policy needs to support profitable enterprises. Here's an important thing in terms of what the role of the irrigator is, apart from having a profitable enterprise. It is important that they understand the impact that their extraction has on the river systems, and that they understand that there are things other than the supply of water in terms of the environmental services that those rivers provide. Diversity is important both agronomically and economically. And of course, if we put water on, take water out of river systems and we put it on the land and we evaporate water, we will accumulate salt. All water contains salt. We will accumulate it. It will be concentrated. We need to be able to manage it. And we need to monitor and adjust. That is, nothing is set in concrete. We need to be able to learn from that which we are doing and be able to adapt as we go along. So the two overarching concepts I'd like to will run through this lecture. Ecologically, nothing is wasted, and nothing hurts me more than to hear people talk about water that's going to waste because it's running out to sea. That is so lacking in understanding of ecological processes. So it means that wherever we extract water, we harvest trees or we replace vegetation, we are having an effect on the biophysical system, on the biophysical processes, and on some living organism. And we need to be aware it is no longer acceptable to plead ignorance, as we have done in previous times. We understand, we know that that's what will happen. It is a question of, let's have a look at the trade that we're about to make, and is the benefit that we're going to gain from this in terms of our well-being worth the trade that we are about to do. And as irrigators, we're part of a complex system, and that has some certain constraints about it, and we're just starting to understand, get a better appreciation of what characteristics we need to work with when we talk about complex systems. It means that the responses and the outcomes are not totally predictable, and despite this is not a Newtonian world. It is not set up like clockwork. There are a heap of lots of interactions and interdependencies about which we are unlikely to ever fully understand. We can only control some parts of the system. We can't control it all. We can influence other parts, so we need to think about those things that we can control, those few things, and we need to think about how we can influence other parts. And we need to learn by doing. That is, recognising that we're not going to be able to control it and only influence parts of it. We need to learn how to apply actions, learn and measure what the responses are, and be able to adjust as a process of learning. So let's now talk to, just to give context of water, and then I'll start with looking at the world scene and Australia's place in it, and then we'll come down and look more particularly about the situation in Tasmania. So in a global context, Australia's outflow of water from its river systems and reflecting its rainfall over a continent is very small by world standards. So our outflow is very small. We deal with a dry part of the globe. Most of that water within the Australian scene is in northern Australia, so the northern part, the three north and northeastern catchments, Timor Sea, Gulf and Carpentaria and northeast coast, which accounts for about 66%, two-thirds of Australia's water runoff occurs in those top catchments associated with those cyclonic summer rainfall events. Then we have a look at Tasmania as the other major water resource of Australia, somewhere between 12 and 13% of the total water runoff. And of course, when you look within Tasmania, of course, it's very much concentrated on the western portion rather than evenly over the island. Those areas, of course, where there are the concentration of people, the southeastern portion and the coastal regions in southwestern west of the continent, is where we've got high demand for water and relatively small amount of the total water distribution in the country. And of course the traffic light signals there indicate the demand for water, the commitment of that water. You see within the Murray-Darling Basin, which is very much in the news at the moment. It's a highly developed area, and the notion that you can just go and build another dam and get more water is simply not an option. It's already highly developed and most of the water is accounted for. Another feature of water within Australia, of course, is its high variability. Our rainfall is highly variable, our river flows are highly variable, particularly on those inland rivers that we have. And as a result, as a community, as a society, we've been prepared to put a considerable amount of public money into water storage. And the MDB there, the Murray-Darling Basin, indicates that as an Australian society, we have put a lot of asset in storage, so we store about 3 years of irrigation water use, provided, of course, that the storages are full. And you see that that's a very at the upper end of the storage and the commitment to that water storage around the world. So we deal with a dry climate, a dry continent, and we have to be prepared to put lots of money into our storage because of their variability. So again, within the last 5 years, we've seen a lot of effort being put into starting to account and audit where our water sources are and how much is being used for what. That's been a good development. Now that responsibility rests with the Bureau of Meteorology. They got $500 million to do that over the last few years and into the future. So this is the data from 2004-05. It was a dry year. You see we're about 100 millimetres on average over the whole continent, less than what we would expect over the long term. Most of that water is evaporated, 8% goes to the surface waters, 2% into groundwater. We consume only about 6% of that total water, 19,000 gigalitres in 0405, of which agriculture uses the majority of it, 65%. Relatively small amount goes to household use. We have a pretty expensive water-intensive system that takes away our sewage, so we use that as a transport system. And you see mining and manufacturing is a relatively small amount. Here's the comparative figures for Tasmania. You see total runoff estimated about 45,000 gigalitres, somewhere between 12 and 13% of the total runoff that's estimated for Australia. Irrigation licences, somewhere around 520 gigalitres currently. But when we look at ourselves relative to the rest of the world, you see that we're pretty comparable. World water use, agriculture using somewhere like 70% of the freshwater resources that are commanded. Industry 22%, so we tend to be a little less in terms of water being used in our industry, our manufacturing, and domestic services we tend to be a little higher. So when you have a look at us on both a national and international scale, ignoring water resource distribution, because we understand that the distribution of water resources around the country is not even, and certainly most of it's in the north. Water consumption is small relative to the total volumes. And on a world scale, we are similar to an agriculturally dependent developing economy, which is interesting, because once you start to see, for example, in the US, its distribution has a much higher proportion going into its industrial and manufacturing activities compared with its agricultural activities. But we are classified on a world scale, we're classified as a country that has an economic shortage of water rather than absolute shortage, and that means that the cost associated with getting water to where people are and where the demand is is limited simply because of the amount of money that you need in order to be able to command it and transport it and put it where people require it. So that will be the limitation. Where is irrigation within Australia? And you see it, we've had an increase in that area particularly since about the 1970s. Fairly significant growth in irrigated area throughout Australia, up to 2.5 million hectares. We're a small player on the world scene, only about 1% of the total world irrigated area. And you see the majority of it's in that southeastern portion of the continent. Then you've got those areas in the northern New South Wales, other concentrated areas up on the east coast, particularly in central Queensland. The big area up there, the Burdekin irrigated area associated with the Burdekin River out of Ayr. But you see even the irrigation development over in the Ord River there, just above where that Timor Sea name is there, doesn't even rate on here. Such a small area, huge volume of water that's commanded in Lake Argyle, but a very tiny area, and will be really struggling because of the climate that it sits in and the distance and the transport costs associated with moving materials in and out of that location. And here's Tasmania's irrigated area, about 55,000 hectares currently, scheduled to increase, of course, with the proposals that are in train. But again, it's a relatively small area when you look at it both on Australian and certainly world standards. So what do we use this water for? Particularly in irrigated agriculture. The majority of water is used in pasture and grain production. And you see there the changes over those periods from 93 to 2004. And since that time, so from 05, 06 up to the current time, we would have seen a decrease in that. It'll show considerably less water being used on pasture and grain over the last 3 or 4 years because of the limitations in terms of water availability and the drought conditions in the Murray-Darling Basin. But one of the things which is really important to recognise is that when our political leaders get up and talk about how much water we're using on rice and cotton, and that we shouldn't be growing rice and cotton, it flies in the face of the fact that we use more water on pasture than we do on cotton, rice and sugarcane combined. So by far the biggest use of water is associated with pasture activities, and in particular has been associated with dairy pastures, particularly in the southeastern portion of the country. And of course we've seen with the drought, particularly in, say, the Goulburn, around the Shepparton area, that's changed in the last couple of years as the dairy industry has had to undergo some pretty major adjustments in terms of surviving with little or no allocated water. These are figures in terms of the value, what do we get for the water we use for the different commodities, and while the figures may be quite old, the relativities are pretty much the same. So we would expect to see, associated with rice, a pretty small return per megalitre of water applied, and of course going up to the higher value products, grapes and vegetables. And of course the interesting thing when you see that is that we know that the value of these commodities goes up and down with monotonous regularity, and of course the relativities will change a little bit as currently if you've got some grapes in the ground it's going to be pretty hard to sell them, and of course the return per megalitre will reflect those commodity prices, and they will vary. But it was very interesting when we had the major national land and water resources audit that was done towards the end of 1990s, 2000, 2002, when we really started to, we for the first time had a major look at what are our basic assets and what's their condition and where are they located and how big are they. And when we looked at that, 0.5% of Australia's agricultural land is irrigated, but it produced 50% of the profit. The sobering thing when you look at those numbers is how few areas in Australia, agricultural areas, actually make a profit. Most of the pastoral areas don't make a profit at all. Most of them are living on their assets or external income. And the only way that they can survive many times is to exploit their asset, which means that the resource base in those areas is declining. But there are the figures. So in rain-fed 470 million hectares with a net return of 3.6 billion, 3.7 billion, but only a mean profit on a dollars per hectare basis of $8 per hectare. It is poor return. Irrigated 2.3 million hectares, 3.8 billion, with a mean profit of about $1,700. And it emphasises why irrigation is so important in terms of economic activity and social viability. So another little comparison which is similar, I looked at, this was associated with a major study on looking at irrigation and its role in the Murray and Murrumbidgee, and I compared two adjacent districts in the Riverland area of Murray Riverland area of South Australia, and I looked at the return per unit of water. So in the irrigated system, irrigated district, you had both rainfall and the irrigation you're putting in. And of course in the rain-fed area, the adjacent rain-fed district, just the rainfall. Calculate how many megalitres per hectare comes in, and you end up with something like a ratio of 2.4 to 1. So there was 2.4 times as much water going into the irrigated area as there was into the adjacent rain-fed area. But the revenue generated was in the ratio of 13 to 1. So a small addition of water increases the economic activity tremendously. That's the reason why we look at the benefits associated with irrigation. And of course here's the proposals. I'm indebted to Chris Thompson for this. Diagram is the proposals associated with the irrigation developments in Tasmania, and you can see there the distribution of them are throughout the state. And of course when you add that up, that comes up to about 170 gigalitres, less than 200 gigalitres, and relative to what did we have before, about 530 gigalitres that's currently licensed. So we're not talking about a huge change relative to the basic resource, and of course it's distributed, and many of these are small focused irrigation developments, and of course, but irrespective of that, they still need to go through this process of figuring out how do we manage this in the long term and make sure that we get the positioning of irrigation relative to the other uses of water. So here are some of the things that I'll cover, with just making some comments about those things that need to come together to ensure successful irrigation in the long term. It needs vision, it needs to focus on governance, planning, the implementation of the plans, the operation, the water entitlements, those things that bound it, the maintenance, the need for review and refinement, the need to plan for resilience and buffering within the buffering against the inevitabilities of both prices and availability of resources, the need to manage for productivity and profitability, the need for control and measurement, and the ongoing need for research to keep ourselves ahead of the game. So in terms of the vision, why do we need a vision? What we need to be able to define and articulate what will this irrigation development look like, and what will the boundaries to it be. So it needs to be clear, feasible and easily articulated. And I'd like to suggest that one of the reasons why we're seeing this incredible outpouring of emotion associated with the draft of the Basin plan is largely to do with the fact that the leaders have not articulated the vision which says this is one river system. Irrespective of whether you're upstream or downstream, you are connected to one river. You are as responsible in the upriver as anybody downriver for the condition of this river. And what we want out of this river is something which says it will serve the purposes in terms of providing extraction water for some irrigation and keep this river system and its ecosystem in a state which will ensure that water actually comes out of the mouth of it and that it remains in a healthy state. We have not seen our leaders articulate that vision. We have not agreed to it. The upstream guys still see that water running past their front door is wasted. And until they go back and reassert that vision, then it will be very difficult for people to come to some kind of agreement and be prepared to take some pain, because we are in the process of having to readjust in realisation that our environment is not as large as we thought and as forgiving as we hoped it would be. So governance. Certainly we've seen some good developments in terms of governance of irrigated areas in recent years. So we've seen a range of public and private kind of activities and governance models put up, and either can work, so long as they are well constituted, understand where their position in and where their interests lie. The public interest associated with setting up these governance is in terms of defining and maintaining those water property rights and the responsibilities to look after the public asset. There is a need to define the water use rules and protect that public resource, and that is those land, the soils, surface waters, the groundwaters and the dependent biota. That is where the public interests lie. So long as you've defined those, then the private interest is in the business of working within those well-defined requirements in terms of looking after the public interest. And governance is not management, and unfortunately lots of times our systems have not understood the difference between governance and management. In terms of planning, so I've noticed the Tasmanian Irrigation Development Board's approach. It says it's going to focus on 3 areas of sustainability: economic viability, environment sustainability and social licence. And I'd like to encapsulate that by saying what it really should be about is we need to be sure that the human well-being, our public well-being, will be enhanced by this development. That means that it needs to be economically viable, but it means it also needs to have an understanding of the trade-off that you're about to make, and that that is an acceptable level of trade-off. It's certainly prudent to be planning for climate change, and I notice the Climate Futures for Tasmania project has been underway for 3 years, and as far as I know has not finalised yet. obviously lots of people involved in that, and I certainly look forward to seeing what that has to say. But let's just do a little diversion in terms of thinking about climate change and the likely effects of that. Our temperatures are getting warmer. This is recorded information. This is not projected information. This is recorded. So certainly in the eastern part of Tasmania, then we're seeing an increase of between 1 and 1.5 degrees over the last 50 years. And all the projections say that that rate of increase is likely to increase. So another 50 years on the continuing high emissions target rate, we may very well see another 2 degrees rise, with a 2 to 3 degrees rise in the next 50 years. And that's a very significant increase in temperature that we're going to have to adapt to. One thing to bear in mind is that increased temperature does not mean that there is increased evapotranspiration. The process of evaporation is driven by 4 principal components. The amount of energy that we get in, the radiation that comes in, the vapour pressure of the air, what humidity we've got in the air, how much water vapour is in the air, which increases as temperature goes up, the amount of turbulence, the amount of wind that we have, and finally the temperature, in that sort of order. Radiation, wind, humidity, or vapour pressure, and temperature. And the evidence from looking at the data from Australia over the last 50 years indicates that very clearly the temperature's gone up, but evaporation has remained pretty much stable or slightly decreased. The major reason appears to be that the conditions appear to be calmer. There's less turbulence. So don't make the assumption that because of increased temperature that there is increased evaporation because of these other interacting components. So in terms of rainfall, again in eastern Tasmania, central and eastern Tasmania, looks like there's been about a 25 to 50 millimetre decrease in the annual rainfall. This is much more variable, but of course there you see in those areas, east coast of Australia, the southeast part and even the southwestern part of the continent have all been affected by a decrease in rainfall. The projections are that we will continue to be going into a warmer, slightly drier environment, and of course the implication of the dryness in terms of the rainfall is the disproportionate effect that a decrease in rainfall has on runoff. And this is an example, this is probably the most quoted example associated with looking in the southwest of the continent, around Perth, the runoff into the Perth catchment, the water catchments. And since 1974-75, it appears as though there was pretty much a step change in the amount of, there was about a 10% decrease in rainfall, resulting in about a 30% decline in the amount of runoff. Of course, some of these things are what you do on the landscape, what you do in the catchment affects what happens in terms of runoff. But this was primarily associated with that decrease in rainfall. So you get a disproportionate effect, which is one of the reasons why we need to be concerned about changes in rainfall. So let's talk about the implementation, back on those things that make successful irrigation. In terms of implementation, so we can go through some great planning processes, we can think about all of those things that are going to affect irrigation, and we get into the enthusiasm of development, and there's lots of energy expended because we're doing something new and people get energised by that, which is great to see. But then you see, and I've seen examples of where great planning has been undone by really poor implementation. Someone needs to take responsibility for ensuring that the plans and the good intentions are delivered. And if that institution or that arrangement is not set up in advance, then it's very easy for people in their enthusiasm to get going, just run roughshod over the best of intentions. We then need to have some audit associated with the continuation and delivery of those plans. And this was an area that I was involved with a little early on. It was in Queensland, and it was like an irrigation engineer's dream. Fantastic planning, fantastic development, very large development, fantastic channels and distribution systems, and they did a great job at the planning. They got people in to talk about impacts on the water systems and on the riparian zones and placement of what they were going to do where. And then you saw the implementation where the authority that had been involved in the planning stepped back, was not involved in the implementation. Nobody took responsibility, and in their enthusiasm, many of the riparian zones were impeded on, dumped in, dug up. A lot of the buffer strips were roared over the top of. You see there examples of where people were just hugely destructive in terms of their management of soils and so on. So it was a case of where the planning was great, but the implementation just wasn't put in place at the time. So if there's a lesson to be heeded, that's one of them. In terms of operation, the focus needs to be on water delivery to crop needs, not on increasing the volume of water delivered. And when we set up institutional arrangements, as I see in California, for example, where you have the water delivery company whose only interest is making sure that they deliver large volumes of water, who don't give a hoot about whether or not it's being used well and whether or not it's in excess of that which crops need, then you end up with a disjuncture between the amount of water which is being delivered, the crop need, and you get resultant problems associated with it, including very large areas which are being affected by salinity. Unfortunately, in the American system, there doesn't appear to be anybody who's really has authority or responsibility for managing that in an integrated way. We need to avoid that kind of thing. Measurement is really fundamental, and no measurement or poor measurement is certainly not acceptable. We need to be able to measure it and account for what it is we're using. Water entitlement. As I've said, this is one of the areas that has really been some good work done on the last decade. It's really important that we try to get our definitions and our language standardised. And unfortunately, we still see differences between the states. In the Murray-Darling Basin, we still have states that use different language for the same things. And it is so constraining. Some have general security water, some have high security water. People are uncertain. What does entitlement mean relative to allocation? It shouldn't be a problem. We know we've got good definitions of those things now. It is important to use some standardisation in order for us to be able to communicate well, irrespective of state boundaries. Water entitlement property right. Bear in mind that under the Constitution, all water is owned by the people, by the government, by the Crown. Under the Constitution, might I say that was a fantastic thing to put in the Constitution. Unlike the American system where you have riparian rights is the way it's set up, all that leads to is lots of well-paid lawyers. So we have a very good system where it's owned by the government. We are assigning a property right now. We are transferring wealth by assigning a property right in terms of water entitlement. One of the biggest wealth transfers that's gone on has gone on associated with water rights and assigning entitlements over recent years. Allocation should never exceed 100% of entitlement. And those licence to use conditions is something that we've really needed to work on and see that irrigation practice, the same as any other industrial activity, needs to have some licence conditions associated with it, with the use of the resources. We assign, for example, when somebody says, well, I need to build a refinery, I'm going to have a foundry here, the expectation is that there will be some conditions associated with operating that in terms of the impact it's going to have on the atmosphere, the soils or the waters or your waste streams or your pollution. Then there's some conditions you need to meet, and you will operate your business within those conditions. The same should be expected with respect to irrigation. And I'm pleased to say that these farm water access plans that I think are part of the irrigation proposals here seem to be breaking new ground, and I think that looks like a great development. Certainly been very keen to see how that's developed and see how that is effective. The licence to use condition must be subject to review, and this is really important, that we don't accept that you put it down and you go away and forget about it for the next 50 or 100 years. Review, because we need to get ourselves into a learning frame of mind, we need to accept that within a set period we will come back and review and adjust if what we thought we were going to do hasn't quite worked in the right way. This is a complex system, so we need to have that review and adjustment period. Water supply costs must pay for maintenance or replacement, and that looks like that's being incorporated into what I've seen so far. Reviews are standard and with known set times. So what seems to be advocated is something like there's a 5 or 10 year period during which time the conditions are set, but at the end of that, towards the end of that 5 year period or that 10 year period, we will have a set time when we will review what we've done and expect that we will make some adjustments. That is essentially gives surety for that period of time, but it also builds the expectation that there will be a review and we will modify and adjust as we need to. Manage for productivity and profitability. What do I mean by the efficiency queen? Well, what we've seen is that the appeal for the answer to all of our problems with respect to the over-extraction of water out of the Murray-Darling Basin is just to increase efficiency. It is a huge trap. It doesn't deliver to everybody's expectations. It has been known since the Industrial Revolution that when you make a process more efficient, its major effect is that it increases the demand, the use and the demand for that process. That's exactly what happened within the Murray-Darling Basin. There was appeal to increase efficiency. Many irrigators did so. They improved their delivery systems. They increased improved their delivery, their application systems. They did not put their water back into the system. They used it to either increase their area of irrigation or to increase their intensity of irrigation. The net result is that the amount of water which is being used out of the system actually increased. There was less slop in the system, so there was less room to be able to manoeuvre and play, and as a result the whole system just went into it was like just sucking it up. The end result is the water didn't flow out at the end of the mouth of the Murray in the last few years. So efficiency is not the answer to everything. It is important to have efficient and effective systems, but don't use it as the way of managing what should have been managed, decreasing the amount of extraction. Be aware of the different drivers, and this is an interesting one. As a government, as the owner effectively of the resource, it is sensible that they should try to maximise the return per unit of resource. Now we have a bunch of bureaucrats who come back and say, well, that's what the driver is as far as you as an individual irrigator is concerned. That is not true. Their driver is about this tricky business of optimising for their particular circumstance and their enterprise the profit, the lifestyle and the social acceptance. Those are things which are not necessarily the same as maximising the return per unit of the resource. So there are different drivers, and it's important that in terms of policy that we understand those different drivers. Be aware that maximum productivity doesn't equal maximum profitability. Again, it is correlated, but it's not exactly the same thing, and we need to be aware that they're different. Plan to build resilience, regional resilience. Diversity is really important because there is inevitability with agricultural production, primary production. The returns will go up and down. And if we set ourselves in a system where we've got a monoculture, an extensive monoculture, then we will end up with a system which is highly vulnerable. Vulnerable agronomically and it's vulnerable economically. And that's not good for our dependent communities. Measurement is really fundamental. And despite the fact that you'll see initial resistance to measurement, because why the hell do we need to be measuring it? You know, it's just more expensive to do so. The thing is that once you have measurement, then you're in the business of having control, and it is empowering People become to understand, now that I understand what's going on and I've got some numbers to back it up, I've really got some credibility and am in a position to be able to negotiate what's being used, where and so on. It's important to monitor the inputs, the outputs and the effects. Learning and adaptation needs research, and if we don't continue to try and encourage our political process to support research, then we will be in the also-ran category. And unfortunately, the organisation that I set up, CRC for Irrigation Futures, does not have a replacement, and when you look at the amount of energy we're spending on trying to manage our water resources, and particularly the impact of irrigation associated with water resources, not having some arrangement with respect to national focus on irrigation and water use is pretty much a disgrace. But the irrigators have a real role to play here. They are credible and they can exert influence if they're prepared to put in, and they can get considerable leverage with that, just with a small amount of input. So that's where the leverage can be, that's where the gain can be made. So just reiterating those key messages. Water resources are limited but renewable. Irrigation increases total economic activity and strengthens social viability. Those things are defining what it is we're trading in and how we're using them are really critical. Those kind of things that we've observed in terms of components which will ensure successful long-term irrigation, everything from the vision right through to governance and management, managing that extraction, keeping it below some levels which are beyond which they are unacceptable in terms of the impact on the environment. Looking out, yes, being efficient and effective in terms of the distribution and application. Having policy which supports profitable enterprises and not propping up those that are not profitable. Getting irrigators, and this is where there's a really important part of getting the people who've got the vested interest involved in, who understand and support that rivers provide more than just water to them. We must manage drainage and salt because it's inevitable that salt will accumulate, and it's important that we adjust. So let me indulge myself for a little and just go back to the messages that I left in 2001 when I was talking about irrigation opportunities, threats and strategies. And these were the things that I thought were important then. Recognise that irrigation is an intensive activity. It's not dry land plus water. More water does not equal more production, does not equal more profit. You need to be able to measure to manage. Irrigation without drainage will not last. You need to manage those salts, nutrients and so on. You need to measure volumetrically. Set environmental standards. Set the irrigation water allocation on the basis of crop need. Amounts used in excess of crop need to become increasingly expensive and untradeable. So I reckon between 2001 and 2010 the consistency of message has been pretty good. So there's a great opportunity for careful expansion of irrigation in Tasmania. That seems pretty clear when you look at the numbers, look at the positioning of it and so on. Provided that the conscious trade-off of public well-being against environmental effects is deemed to be positive. We are making a trade and it's important to recognise that. We should not ignore it. The learning from other areas is heeded, good intention and great planning are realised. So Tasmania has that opportunity to start a new era of productive and vibrant irrigation, and the world is watching. Thank you very much. I'm happy to take some questions from the floor if people have them, so please raise your hand. And question, okay. Where's?
Well, I'm actually asked this question in my capacity as the General Manager of Water and Marine Resources with the Department of Primary Industries. From a water management point of view, where on one hand the government's initiating irrigation development through irrigation schemes for which farmers will pick up a large cost of management, but we still run a water extraction system out of a river system where farmers pay very little. How in your view, does the government manage those policy objectives where one set of farmers have to pay and the other don't?
So the question is about how do we reconcile that there is some farmers who pay little for their extraction and others who are going to pay pretty much good market prices, I guess. I guess my response would be fairly simple. You need to charge those who are currently getting theirs for little. Without that, then you know, it's the recipe for disaster, basically. And we've seen that. I mean, the whole story of the Murray-Darling Basin, the whole story of the Snowy scheme is 10% more water came into the basin as a result of the Snowy scheme. Huge investment in terms of the national system. The price, in order to encourage people to use it, we set up the whole Colliambly irrigation scheme as a result. The whole price for water was decreased on a per unit basis as you used more. The net result was we've ended up with water tables and salinity 40 years, 50 years down the track, which is now going to cost us more. And it was because we failed to recognise, it's one thing to encourage people to use, it's another thing to encourage them to use it both productively and very well. So without giving the right kind of signals right from the start and recognising this is a resource which is worth something. And it's important that we as a community have an expectation that we'll charge for it.
Yes. Yep.
How much holistic planning goes into what you talked about, the planning stage? I'm thinking about, for example, whether there are markets for the vast expansion of certain crops that are likely to come out of this. If the markets aren't there, then of course another disaster will come out of it. It's a chicken and the egg situation, I know. Do you know, for example, with the Murray-Darling Basin, for future planning, are they going to look more at what the markets are? If they're going to bring importing cheap vegetables from China, for example, should they be planning for irrigation for vegetables, for example, for us?
So the question is really about, well, let me paraphrase, the role of deciding what you should grow in order to ensure that you've actually got something which is saleable and marketable. I guess I take the general view, it's a bit like really comes out of this discussion that's where people have a look at the concern for how water is being used and the extraction of water, particularly in the Murray-Darling Basin context, and they say we shouldn't be growing rice or cotton. Well, governments are particularly poor at picking winners, and it's not the public interest. The public interest is in looking after the resource base and making sure that, for the most part, it's used to the best, in the best possible way and with controls on it, so that you don't stuff it up in terms of that resource base. We should not be telling people what they should grow. So I wouldn't, while there should be concern about it, I mean the private interest is really in, here's our resource, here's the conditions of use that we need to operate within, and they need to be well defined. Here's when you can get some access to water, but it's really the private interest which is should be about looking at what those market opportunities can and should be, and having them take that risk. I don't think should not be the public taking that risk.
Where are the standout examples around Australia where irrigation schemes have been established and run like clockwork according to your guidelines?
Where are the examples around Australia where irrigation has been set up and practiced in the ideal, according to Meyer? I mean, the fact of the matter is that there are very few places where those kind of things have been set up in their entirety. That kind of components have all got there. But there's certainly some examples where we've made considerable improvement, and I'll give you a couple of examples. Certainly in the Riverland in South Australia over the last 25 years, there's been considerable improvement. It went from a system where there was effectively government control, government management of the irrigation system. It's gone much more to a corporatised system. There has been rehabilitation of many of the irrigation areas, conversion from open channel systems to water on demand pipe systems, with the expectation that they will pay for the price. So the costs have gone up in terms of being able to pay for the maintenance of the system, and you've seen the productivity of the system has gone up tremendously. It also meant that there were some hard decisions about we will not supply water to everyone. There are some other areas, for example, in the Burdekin area, I think they did a good job at setting up initial planning, but their follow-through, they are at risk because they've got pretty extensive monoculture in terms of their sugar system. They grow sugar cane. So there are some other areas around. You can look at some of the rehabilitation that's going on, say, around Melbourne, out at Werribee and so on, and you can see some of those components have been put up. The Gippsland guys have also done a good job at upgrading their systems. But a lot of them have got a lot of history and a lot of baggage that they carry along, and that's very difficult to overcome, in a short time frame.
One last question, please. As you know, the system that's being deployed for the definition or the design of the schemes here by the Irrigation Board, social licence, environmental, the economic criteria is based on take a stance, I suppose, on a methodology as to how to evaluate that, and it's based on very conservative parameters, existing sort of land use, crops, and a certain percentage offtake commitments from the farmers. There's a risk here of under-dimensioning the schemes with those parameters in place, given that there's probably this is a once in a generation chance to dimension things, future-proofing. Have you got any comments about that?
So the question is really around, I guess, the economic assessment, particularly being a little too conservative in terms of the amount of, presumably in terms of the amount of infrastructure and so on that's going to be put in place. I don't see that as a bad thing. I think that's that's probably a sensible position to take. But you would certainly want to have within that planning the again this notion that we will need to refine and adjust. And I would think that the adjustment is not necessarily always going to be, well, actually we did too much of that and we've got to come back. Maybe the adjustment has to be, we could do some more of that and we can supplement it. So having plans which have got that capability would certainly be prudent. Certainly be prudent. And I see, certainly from the surface of it, certainly that looks like there's good opportunity for us, at least some of those schemes, to have that built in.
All right, folks, you've hung in there very well. It's a very entertaining talk. I'd just like to invite Richard Doyle, the President of the branch, to move a vote of thanks.
Yes, thanks everybody for coming along and supporting the inaugural Mike Temple-Smith lecture by the Soil Science Society. It's been very reflective and a wonderful detailed overview of what's happening on the mainland and the implications that it has for us here in Tasmania as we go through this change. I've got a certificate here which I'd like to offer you as a small token of appreciation. So I'll pass that over now. Thanks, Richard. And those people that are in the branch, I'll remind you that we've got an AGM in a few minutes, so if you want to stand up and turn around. The rest of you, thank you very much for your attendance, and we'll be having another lecture next year. Thank you.
Thank you.